right, so finally we're getting to some true calculus. So let's actually go through the first page here to kind of motivate, I think, um, what what exactly we were doing from the sake of the warm-up. All right, so if I've got this function here, what's the difference between a secant line and a tangent line? Right, so if I draw a curve of any sort, right, a secant line goes between 2 points on the curve, and a tangent line only touches at one. So when did you guys first run into tangent lines? Should have been even before that. Yeah, let's talk geometry, right? Because you talked about tangents to circles, for example, right? Okay, so great. The so the idea behind the derivative is, what about if I make this point and this point get really, really, really close to each other? Then what happens? The secant starts to approach the tangent, right? And from the technical perspective, how do we make it get really, really close? Well, that's the whole point of the limit. But for right now, let's just compute, if I've got here, what was it? F of x is x squared plus 2x. Also, has Feller sent out his like weekly missive? Okay, I've been like hitting refresh like every 10 seconds to see if we have, if Dobby will be a free elf today. Huh? Oh, yeah. That, you know what? Oh, I just thought of it. Okay, you guys have to keep a secret. On April 1st, as a prank on all the other EQ classes, we need to like assign the collected works of Feller, and it just be like all of his emails. Okay, but you guys are all sworn to secrecy about this idea. Okay, right? What do you think? Yeah, okay. Um, all right. Good. So there's a function, and the points that we picked are 3f of 3. So what is 3f of 3? Well, 3 is the x coordinate. What's the y coordinate? 9 plus 6 is what, 15? All right, and then the other point that we picked just sort of arbitrarily here is 5f of 5. So the x coordinate's 5. What's the y coordinate? 35. Okay, great. All right, so what's the slope between these two lines? Or 2 points, excuse me. Yeah, it'd be what? 20 over 2, so 35 minus 15 all over 5 minus 3 is 2, last time I checked. Okay, good. Oh, let's try that again, shall we? The jitter liquid hasn't kicked in yet. Okay, 10, right? So that's the slope of the secant line here that's in red. Okay, does that make sense? Now, if we take, for what value of h, oops, sorry, I meant equals there, is this true? That shouldn't be too big of a shock. Yeah, h equals 2, right? Okay, so if we plug that expression into h plus 8, what do we get? Okay, so if h equals 2 and we plug that into h plus 8, okay, so if h equals 2, h plus 8 would equal 10. Okay, so if we were going to do that, right, we would be plugging this in, this value of h, and the way we want to think about it is we're going to start at 3 and go however many units over, h units over, to get wherever we want to go. Okay, all right. Now, what happens in the expression, Well, okay, we'll come back to that in just a second. So in our expression here, the stuff that we computed here and here, do we have h in it at all? No. Okay. But what could we think of f of 5 as being? It's really f of 3 plus h, where h was equal to 2, right? Yeah? Okay, so why is that happening? That's so weird. I think one of these HDMI cables is kind of janky, so, I've only got like 17 of them up here. Okay, so let me actually erase this just for right this instant. So what we basically just did here was we found the slope between 3f of 3 and 3 plus h, comma, f of 3 plus h, but we did it with the specific value of h equals 2. Could we have done this instead with h just equals h and not plugged in a number? Okay, now if we did that, we'd have a little bit more arithmetic to do, because what is f of 3 plus h? Okay, and this is something that you guys have been screwing up left and right on the assessments. What was f of x? X squared plus 2x, right? All right, so what is f of 3 plus h? I replace every x with a 3 plus h, and then I'll simplify it later. Okay, now, is that mystifying? I know it's 8 in the morning, so maybe it is. Where the heck is everybody? Huh? We got some fresh powder? I don't know. Somehow I don't think of some of our missing compatriots as skiers, or football fans for that matter. So, yeah, how many of you guys did watch the game last night? Yeah. Did anybody not watch the game? Yeah. Anybody watch just the commercials? Who watched the Puppy Bowl instead? No. Yeah. No. I did too, but okay. So we've got some algebra to do here, but what do we get? We get 9 plus 6h plus h squared plus 6 plus 2h, right? And then if we do the same thing that we did a minute ago, which was the slope business, then we need to do this minus the old value, which was what, 15? And this would all be over, well, okay, so this is going to be kind of funny. What's 3 plus h minus 3? It's just h, right? Well, that kind of makes sense, because every time we do one of these difference quotients, what's always been on the bottom? Just h, okay? Now, what's the story in the numerator? After I simplify all this nonsense, what do I get? Well, the 9 and the 6 cancel with the 15. Does anybody else cancel? Nope, not in this case. All right, and so what do we get? We get 6h plus h squared plus 2h, which of course I could simplify. Notice everybody's got an h in them, so what do I get? I get 8 plus h. That looks familiar, right? Okay, so if we plug in h equals 2, which is what we had when we started with this, what do we get? Which is the slope that we started with. Okay, so this jives. Hmm. Um, but there's one other thing here. Did we have to do this at 3? Was there anything special about the number 3? I mean, I picked it as sake of demonstration, but could we have replaced 3 here with another variable? Yeah, what would be a good choice for that? I. Did you just say I? Oh, 5. Okay, that's not a variable. It's a number, right? Let's replace it with A, right? So we just did this computation with A equals 3, a specific number. Could we replace it with a variable and then our work should work no matter what? Yeah? Okay. So that's the next thing we want to do is let's say that we go from A comma f of A to A plus H comma f of A plus H, right? So now we're thinking of both our base point and the amount that we go away from it as being variable quantities, okay? All right, so unfortunately we have to kind of redo a little bit of the algebra, but really not too much. This is the only one we really need to recompute, and our function was x squared plus 2x, so this would be, what? A plus h squared plus 2a plus h, right? All right, so now what? Let's just do some algebra. What do we get? A squared plus 2AH plus H squared plus 2A plus 2H. And can't really clean that up any. So we'll just leave it as is. Okay? All right. So if that's my point, so the slope of the secant between, and I'm going to use a fun word this morning just to keep you guys all on your toes. You guys have seen this word before. Betwixt. It's a very old-fashioned way of saying between. Like, 1,000 years ago kind of thing. But yeah. All right. So what's the slope of the secant line between them? Well, what do we got to do? We got to do a rise over run computation, right? Okay. So what's the rise? The rise will be f of a plus h, which is all this mess that we just computed, minus f of a. Well, what's f of a? A squared plus 2a. Yeah? Okay, and then what do we have in the bottom? We go from a plus h, and we subtract, a, which is what? Just really in the bottom? H. Okay. But all we're doing here, right, is a rise over run computation. Okay, now, can we simplify things at this stage? Yeah, because we got two things we can do. First off, in the denominator, we know it's just h. That's easy. What about in the numerator? What cancels? The a squared cancels, and the 2a cancels. All right, and so we're left with 2AH plus H squared plus 2H. Okay, everybody in the top has an H in them, right? So can I cancel? Yep, and so I would just get 2A plus H plus 2. Okay, does that make sense? Okay, so look at the table down there at the very bottom, right? Um, for the given values of A, okay, -2, -1, 0, 1, 2, and so on, okay, plug those values of A into the formula we just got, okay? Now, 8 plus H was the value we got before when we were doing this at A equals 3. That was the specific value. Okay, so that one we already knew. But what about the rest of these? Okay, so all we're going to do is plug in the given values of A in the table into this, and we're going to get some expression. It'll still have an H in it, and that's okay. Okay, so let's do that. Okay, so compute all of them, and then we'll see if the peanut gallery agrees. So while you guys are doing that, I'll sort of copy down the table. All right, so what did we get at -2? -2 plus h, agreement? All right, what about -1? H. Okay, which I'm going to be pedantic and write as 0 plus h because it'll make the pattern obvious in a minute. All right, what about at 0? 2 plus h. What about at 1? 4 plus h. What about at 2? Huh, that looks interesting. All right, so based on this, what do you guys think the value of the derivative is? Okay, so what's the difference between the derivative and, well, what is the derivative? What's the idea? It's the slope of what? The tangent line. Okay, do we have any tangent lines yet? No, we have a bunch of secant lines. But how do I make a secant line become a tangent line? Making them as close as I can. And in terms of calculus, that's code for letting h, which was the horizontal distance between the 2 points, taking the limit as that goes to 0. Okay? All right, so if h just magically turned into 0, what would we get here? -2, 0, 2, 4, 6, and 8. Okay, does that seem reasonable? Okay, yeah, and it is. Okay, and for that, we could also graph this and then kind of see, hey, does that look reasonable for the slopes? All right, so let me pop over to Desmos real quick and let's do that. All right, so let me get rid of you. So what was our function? X squared plus 2x. And then let me zoom out and find the thing. Okay, so let's just take, for example, the point 0, okay, which was there. If I go back to my table, then that's a equals 0. What did we get for this slope? So in our table, what did we get for a equals 0? H plus 2, right? Okay, so what I'm going to do is I'm going to draw a line that has slope 2x, and let me change the color so it's easier to see. Okay, all right, so looking at what I've got here, does that look like it's tangent to that parabola? Okay, and is the slope what we computed a minute ago? Yeah, so does this look pretty reasonable? Yeah? Okay, so this is sort of the, I guess, motivation behind the derivative, and I'm actually going to show you guys one other way to do this. So that works only for parabolas. Okay, so you guys agree we have a nice little parabola there, right? Okay, and we've got the tangent line that I drew it in. But I'm going to show you another way to construct this. Like I said, this will only work for parabolas, but it's an ancient result, which I think is kind of cool. Okay. All right, so let me go back to the sheet. Oops. All right, so let's talk some history for a minute. In geometry, if I gave you a point on the circle, say this one, and I asked you to draw me a tangent line, well, what's it going to end up looking like? Something kind of like that. But in terms of like constructing it, right? So when you guys were in high school geometry, did you guys bust out compasses, geometers, compasses, and straight edges? You guys never did straight edge and compass construct? Oh my Lord. Okay, so how would you have constructed this? I mean, yeah, I just sketched it, but like what property is important about, like, how do I know that that's exactly the line I should have drawn? If this is a circle and I want a tangent. Huh? Well, I got the little tool, yeah, but how would I have used the tool to get this? Let me erase it. Actually, interestingly enough, no? Yeah, okay, so I'm going to draw the radius, and then at that point, I'm going to construct a perpendicular to the radius. Okay, that is the tangent line. Okay, and if you don't believe me, it's Euclid's Elements, Book 3, Proposition 16. Okay, okay, that's cool, but that only works for a circle. What about other shapes? Well, got to do something else. So let's take a parabola. Okay, let me just draw one. Okay, so there's a couple of terms here. This is obviously the vertex, and that is the axis, okay, which you might have called it like the axis of symmetry back in high school or something. That's fine, but we'll just call it the axis. Perfectly good, right? All right, so what I'm going to do is if I choose a point on here, let's say this one, and let me erase the word vertex just to clean this up. If I drop a perpendicular to the diameter, what is this segment called, which let me label it with A. Okay, so A is from the vertex to wherever that perpendicular dropped. Does anybody happen to know what that word is that A is short for here? Well, I'll give you a hint. It starts with an A. Nope. I'll even give you the second letter. Nope. The abscissa. Have you guys ever seen that word before? Okay, well, this just shows you the declining state of education in the world because it's from Latin. And of course, you guys all took Latin in high school, right? I did. I'm being sarcastic, right? Um, yes, okay, so it's from the Latin verb abscindere, which means to cut off. Now, there is actually, you guys should have known this because what do you cut things with? You cut them with scissors, right? Yeah. Okay, so it's the piece of the axis that got cut off. Okay, make sense? Um, and while we're on the subject, what's this segment called? That one's called the ordinate. Okay, you guys never learned these words? Well, you're learning them today, right? It's too bad you don't have to take the SAT anymore to impress people with your vocabulary. There was? Yeah, it's kind of going the way of the dodo, which is unfortunate because, you know, well, here, really unfortunate. So you guys have certainly heard of Plato before, right? Famous philosopher, right? So at the academy, which is basically the place where they all hung out and did philosophy, there was a big gate. What was written above the gate? If you wanted to go study philosophy with Plato, what was the prerequisite for doing so? Above the gate, it said, Ageometritos medes cito. Let no one enter here without geometry. That was the prerequisite for studying philosophy and being educated. And damn it, now what? We don't even teach this stuff anymore, kids these days. All right, so what I'm going to do is I'm going to extend the axis by a length equal to the abscissa, okay? And then I'm going to connect this point and that point, and ba-bam, that's the tangent. Yeah? So, yeah, now, if we go back to our GeoGebra, let's look at it and make sure, oh, thank you, Go Gadget Wabash Wi-Fi. Right, does this jive? Well, I've picked a point. Where's the axis for this parabola? It's here, right, at x equals -1. What's this length from the vertex to where the perpendicular would be drawn? 1 unit. So if I extend 1 unit past the vertex, drop a point, and connect it with the given point, it's tangent. Okay, that's pretty cool. Yeah? Okay, but this trick only works for parabolas. And if you want to read all about this, I invite you to read Apollonius's Conics, which is a much harder work than Euclid. And now then you could say, well, what about other shapes? Like, what about ellipses? What about hyperbolas? What about spirals? What about, right, a bunch of other interesting curves? Ancient mathematicians figured out a lot of these things, but they had to do them kind of on an ad hoc basis, if you will, meaning the techniques that worked for one curve didn't necessarily transfer to a different curve. Okay, so what's the brilliance about the way that we did it a minute ago when we were doing this table? Was there anything about the actual construction of that table or that idea that depended on the fact that we started with a parabola? We just had some function, right? We can plug whatever the hell we want into a function. Okay, so this is sort of, we've one-upped the ancients. Like, take that, Archimedes. Yeah. Okay, so make sense? Kind of cool, hopefully. All right, so let's go in for the kill. So if we go to the backside here, we've actually already plugged in all of these things, right? So what goes in the first box or the first row that we need to fill in? What goes in the first set of parentheses? Yeah, it'd be limit h goes to 0 of a plus h squared plus 2a plus h minus a squared plus 2a all over h. Well, we've already computed what this simplifies to. What did we get? It was over here. 2a plus h plus 2. Right? So that numerator is exactly what we were working with a minute ago. And we FOILed everything out and we simplified. And what did we get? When all was said and done, we got 2a plus h plus 2. Okay? If I let h go to 0, which I'm doing now because I have a limit, what do I get? 2a plus 2. Okay. Now, this is at the point A, okay, where the x coordinate is A. Did I really have to use a separate letter for the x coordinate? Let me just let it be x, okay? So f prime of A is 2a plus 2, or we could say it this way, that f prime of x is 2x plus 2, right? It's just changing the letter. Okay, now why is that maybe a good idea? Because if I want to graph this thing, then I kind of need to have x's in it because that's what all your graphing things expect, right? Okay, so what is the derivative here? It's a new function, right? All right, now, how many of you guys knew it was going to be 2x plus 2 before we even started this whole charade? Bad. Bad student. No. Okay, you don't know that yet. Right, there's some tricks. You guys seen the tricks before? Some of you have seen a little bit of calculus. You don't know the tricks yet. Right? Okay, we'll get to the tricks. But anyway. Okay, so let's do some actual ones here that require a little bit more thought. So look at number 1 and look at number 2, and what I want you to compute are the following things. Limit as h goes to 0 of f of x plus h minus f of x all over h, or for the other one, what's going to change? So that's what you would compute for number 1 there at the bottom. What are you going to compute for number 2? Well, it's not f anymore, it's what? G, okay. And it's not x anymore, it's t. Okay, so 1, 2, you and Cannon. 1, 2, 1, 2, 1. Hit the boards, or some of you hit the boards, okay? And do either 1 or 2 as I have assigned you, and then we will discuss.